here's the goal. This one's, we're solving an exponential equation. And before, when you were solving this, you usually had something, this is an example, 3 to the 2x equals 3 to the, I don't know, let's say 9, right? So we use logic at this point. If 3 to the 2x is equivalent to 3 to the 9, then what? Then if 3 to the 2x is equivalent to 3 to the 9, then the exponents must be equivalent to each other, correct?
Yeah.
Okay, that's a logical concept, so then we just set the exponents equal to each other, right? And then solve from there. So when you're looking at this one, it's the same concepts, right? But you've got more happening. On the left side of the equation, you have a product, right? We have this factor and this factor. So before we get into setting the exponents equal to each other here, we need to transform the left side of this equation right here. So it's some base to an exponent only. And right now we've got two factors that are powers with exponents, and we have to combine them, okay? So what you want to do is you want to look at all of your bases. There's three main pieces here. The 16 on the right, the 64 in the middle, and then the 1/16 on the left. You want to rewrite those as a power, but all in the same base, right? So you want to look at the values you're given. 1/16, 64, and 16. And when you rewrite these in the power, at this point, you want to rewrite them in a power with the smallest possible base. So I'm seeing 16, 64, and 16, or 1/16, 64, and 16. So the first thing that pops in my mind is 4, okay? But that I could also use what base? 2. So go to base 2, because if you go to base 2, what you're doing is you're setting up the problem in you're almost like simplifying it at the same time, and you don't realize it. So the smaller base you work with, the better in this case. So if we're going to do 2, then 1/16 can be expressed as 1 over 2 to the what? 2 to the 4th, and then it's to the negative 2n. And then for the next factor, 64 is what? 2 to the 6th. And then it's to that exponent. I'm going to group this exponent, 2 minus 2n. And then 16 is also 2 to the 4th. So far, so good? We have to work, our goal right now is to work on the left side and somehow get the left side and combine it. So we just have 2 to a power, 2 to an exponent. And right now I have 2 different pieces. So first of all, this 1 over 2 to the 4th on the far left, we want to, it's really, this is kind of like 1/2 almost, right? So I want positive 2 in the numerator. How do I do that? How can I rewrite this 1 over 2 to the 4th so it's just 2 to the what? Tucker.
You put it to the power of -1.
Or it could, I can expedite that and also say it's going to be 2 to the negative 4th, right? 1 over 2 to the positive 4th is going to become 1 over 2, or 2 to the negative 4th times, or raised to the negative 2n. We can rewrite the middle factor right now as is. And some of this, you guys are going to be kind of doing multiple steps at the same time, and that's okay. You need to be justifying what you're doing. All right, so for the 2 factors on the left as powers, I have a power to a power, so I have to deal with that. When you have a power to a power, what's the rule? Multiply. So the left factor here becomes 2 to the what? The right factor becomes 2 to the, and we distribute to both because we're multiplying 6 to the 2 minus 2n. So that's going to leave me with 2 to the 12 minus 12n equals 2 to the 4th. So far, what are your questions? No questions? Okay. Don't get into the habit of dividing stuff at this point. If you have factors that are expressed as powers, 2 to the 8n, and then over here 2 to the 12 minus 12n, don't try to divide 2 to the 8n on both sides of the equation. You're trying to condense that left side into 1. So right now, both of these factors have a base of 2, and we're multiplying. So when you're multiplying the same base, you keep the base the same and do what to the exponents? You add them. So then that's, long format here that many of you are gonna kind of bypass is 2 to the 8n plus, and then 12 minus 12n equals 2 to the 4th. So the exponent on the left can be condensed to 2 to the, what's that, negative 4n plus 12 equals 2 to the 4th. We're almost there. What are your questions? All right, so 2 to the negative 4n plus 12 is equal to 2 to the 4th. If that's true, then the exponents must be equivalent because the bases are the same. So then logic says negative 4n plus 12 must equal 4. We solve. Subtract 12 from both sides. Divide negative 4 to both sides. N equals positive 2. It's more intense, for sure. And you'll see these questions with radicals in them or fractional exponents in them. It's all the same. So you've been building those skills with rewriting as powers and your exponent properties. And now we're kind of, taking larger expressions now and trying to condense them into, a base to a power equals the same base to a power. And then you use that logic step. You want to try the next one on your own? Okay. Go for it. I'll get that right there.